In my last video, I said, so all these other things I have in the background are like 3D printers and tools and other things, and that's really not relevant to my aviation. But today, that's going to change. Hello aviation enthusiasts, this is Jaden and welcome aboard Jetstream Journeys. In this video, I will be showing you how I built my 3D printed, remote controlled flyable Airbus A330. This project is divided into 3 separate videos, and this first part will go over the designing and electronic prototyping process. This project dates back to February 24th, 2024, when I saw there were people on social media building remote controlled airplanes from those kits you can buy online. And I decided it was pretty cool and I want to build my own remote controlled airplane because I want to be able to fly it. And at this time I was just getting into aviation. So what would make my RC plane unique? Well, my favorite plane at the time was the Airbus A330. I have no idea why. It just looked like a good plane. I thought it was a cool plane. Even a lot of people in Flight Simulator like the plane because of the way the airplane flies, the airplane behaves in terms of the characteristics of its flight. And I want to replicate that plane and make it flyable because I haven't really seen any models of that plane, like flyable models of that airplane online. So I think it'd be a pretty cool project, and why not? Why don't I just buy one? Well, I just want to experience the journey of being able to build one on my own. And I thought it would be a pretty cool project because if I build one on my own and perhaps I crash it, I can always fix it myself without having to buy entirely new kit. Now, before I start designing, I have to figure out what type of software I need to use. And the software I chose for this project is Autodesk Fusion 360 for the design. And I chose that because mainly just I've seen many videos of this software being used online, and I've already kind of familiarized myself with this software, and I just decided to be my best option. Starting with the fuselage, I imported side, top, and front view reference images of the Airbus A330 into Fusion 360 to make sure the proportions were accurate, and I measured out how large I want this replica to be, and then after that I just traced the general shape of the Airbus A330 from those images, and I made sure to get exact specifications of the real Airbus A330 from Airbus. February 25th, 2024, I finished the basic shape of the fuselage and started designing the wings, but at the time I did not know what was the real magic behind planes that actually make them fly, other than the 4 forces of flight, which is necessary for planes to fly. But what is so special about the wing that makes the airplane fly? Well, I had to sit down and study for hours on end to figure out what causes lift, how do we take these big heavy metal tubes up into the air. So I sat down and did some research, and now I'm going to share my knowledge with all the aviation enthusiasts. Let's start with the 4 forces of flight. Thrust. Thrust is the forward moving force that pushes the aircraft through the air. It is generated by the engines in 2 ways. By a propeller, which pulls air back, so pulls the air in front, it pulls the air in front of the propeller and pulls it back, and that's what causes the thrust for the aircraft to go forward. Or by a jet turbine, which pulls air in and pushes the exhaust back. So you'll find jet turbines on Airbus A330s, like big airliners like the Airbus A330, even the A320, the Boeing 737. You'll find it on all those big planes that travel long distances. And propellers, you'll commonly find them on small general aviation and business aviation aircraft. Thrust works against drag and gives the airplane the speed it needs so the wings can create lift. And speaking of lift, lift is the upward acting forces of an aircraft. It is created by the wings as air flows around them, creating a pressure difference that pushes the aircraft upward. Drag. Drag is commonly referred as the backwards acting force imposed on an aircraft in flight. It is caused by air resistance pushing against the aircraft as it thrusts forward. Drag increases with speed depending on how aerodynamic the aircraft is. Weight slash gravity. Weight slash gravity is the downward acting forces of an aircraft. Now weight slash gravity, like it could be referred to as weight or gravity, but they both mean the same thing. It is the downward acting forces of an aircraft, meaning like the aircraft wants to go down. It is caused by the pull of gravity on the aircraft's mass. So it could be different, like you could be flying at perhaps a certain speed and the aircraft wants to maintain level flight, and you could be flying at lower speeds and the aircraft and weight will be greater than lift and the aircraft will want to go down because of the gravitational force. Weight slash gravity opposes lift, and lift must be equal to weight to remain in level flight. So if we have about 2,000 pounds of aircraft, or 2,000 kilograms, right? Let's say we have 2,000 kilograms of aircraft weight. We need 2,000 kilograms of lift in order to counteract the weight. That means if we have 2,000 kilograms of lift and 2,000 kilograms of weight, and they both are equal and they cancel each other out, we'll maintain level flight. Now 2,000 kilograms will vary according to your aircraft's weight. You'll have to check your pilot's operating handbook to find your aircraft weight, and you'll have to do calculations to get that info if you're loading your aircraft. Now, what is the magic that makes airplanes really fly? How do we get these big, heavy things in the air? Well, it's mainly dependent on the wing. Aerospace engineers spend their lives designing different types of wings with different curvatures, the thickness of the wings, and the wingspan for different types of aircraft. Whether you're flying an aircraft that's designed to go at slower speeds and needs to stay in the air, or you need an aircraft that's efficient and flies at high speeds, perhaps like 500 knots, for example, 600 knots. And these aerospace engineers spend their lives designing these aerofoils, which is like the aerodynamics of an aircraft, to figure out, right, what's best for this type of aircraft. How can we make a wing that's perfect for a specific aircraft to carry people from point A to point B? How do we carry all this weight on a wing? Well, wings are designed to change airflow around them in a very specific way. When the airplane moves forward, air splits as it reaches the front of the wing. The wing's curved top surface forces the air on top to travel faster, while the flatter surface on the bottom makes the air going underneath the wing move much slower. This speed difference creates a pressure difference. Because the air is moving faster on top, there's a lower pressure area, and because the air is moving slower on the bottom, there's a high pressure area. And because the pressure wants to be equal, right, high pressure will go to low pressure. But because the high pressure is on the bottom and the low pressure is on the top, in order for it to get there, it has to travel, and it travels up to get there. So that's how lift is created, by the pressure differences between the airflow around the wing. So knowing the basics of flight and how wings work, I started designing the wings similar on my remote-controlled Airbus A330, similar to the real Airbus A330, although I did have to make a few modifications and adjustments so the airplane can fly at much slower speeds, because my remote-controlled airplane is not going to fly at 500 knots. That is theoretically not possible for an RC airplane with such small motors to even go that fast. Otherwise we'd probably have faster airplanes. But basically, I wanted my airplane to fly at slower speeds and fast speeds, but mainly slower speeds without the loss of lift, assuming zero flaps is being used. You may be asking, how do we minimize drag so the airplane flies smoother? And hold that thought, I'll get back to that question later. Once I was complete designing the wings, I started focusing on building the control surfaces, which includes the flaps, the elevator, the rudder, and the ailerons. I designed those as separate pieces that will fit into the airplane during assembly, so I don't have to use extra material on creating supports during the 3D printing process. I designed cutouts on the fuselage so these control surfaces can be fitted in, and I could always add motors later to the airplane. It is now February 28th, 2024, and I almost finished the design process. And let's go back to the question of how I can minimize drag so the airplane can fly smoother. Well, to put it simply, the fuselage, wings, tails, and engines have to be designed to let the air flow over them and not just resist. The air has to be flowing over them smoothly so the airplane does not encounter as much drag. It doesn't encounter much drag, thus reducing performance. Air is basically a fluid. It behaves a lot like water, but you cannot see air. Air is a gas. Remember, it's like a fluid. It moves around objects, it has its own resistance, and air is made up of tiny particles that are constantly moving. When your airplane flies through the air, those particles hit the airplane surfaces, and if the shape is smooth and aerodynamic, it'll move around the aircraft easily. So if I have, let's say, I'll put an image on screen. Let's say I have a cone, for example, right, with a pointy end, and I push that through the air. I will barely feel it trying to resist. Like, I'll barely feel it trying to push back on me. But if I take a, let's say, giant piece of flat cardboard and I try to push through the air, I'll feel resistance, and it'll be much harder to push that through the air than the pointy cone. So, going back to minimizing drag, the goal is to design every part of the aircraft so those air particles can flow around them smoother without any resistance. It is March 2nd, 2024, and I am finished the design process. At this time in my grade 9 English class, I am doing something called a passion project, where I take the things that I'm passionate about and set a goal, create something, or improve on that passion. And I figured that because I'm passionate about aviation, 3D printing, and engineering, I decided, why not bring this project to my class? So yeah, that's what I've decided to do now, and I cannot wait to show everybody when I'm done this project. Before printing, I need to review that I am satisfied with everything, like the airplane design, the aerodynamics, and a little bit of electronic testing through Fusion 360 prototyping software. So I went through each component one at a time, starting with the fuselage, the wings, the tail section, the engine mounts, and all the internal supports to confirm that everything will fit together properly during assembly. I checked for things like, are the walls thick enough for 3D printing? Are the control surfaces spaced properly? Will the servos fit in their compartments when I assemble them? Do the wing and tail joints align correctly? And is the center of gravity in a safe range? Because I don't want the aircraft to be too heavy forward or too heavy aft of the center of gravity. Small design issues can become big problems when you start printing. So this step was extremely important because I don't want to waste material. I don't want to have to go back and do work twice. I don't want to have to, like, I'm going to expect some things, but I don't want to have to fully do an overhaul of the aircraft just because I made one little mistake that caused the whole aircraft to be, let's say, front heavy or back heavy. So after I did all the checks, I exported this airplane model as a STL file, which is basically a file that I could put into 3D printing software, and it'll convert that to instructions the 3D printer can read and print my designs. And this officially marks the end of the design and prototyping process. And that concludes part 1 of how I built my RC A330, from the design phase to prototyping and testing and learning a little bit of science on how airplanes work. In part 2, I'll take you through the 3D printing process and the avionics of how I did everything like how it actually flies, remote controlled, and the lighting and all that. And I'll show you the challenges I ran into during 3D printing. And yeah, that's it. If you enjoy my content, don't forget to subscribe and like this video. And if I can improve, please leave a comment. And thank you, aviation enthusiasts, for watching this video. Have a great day.